Welcome to Cosmic Voyages. Today, we're embarking on an incredible journey through time itself. We'll explore the profound questions. How did time begin, and how will it end? Buckle up, because we're diving deep into the mysteries of the universe. Hi everyone, and in this episode, we're tackling some of the biggest questions in cosmology. What was the spark that ignited time, and what fate awaits it in the distant future? Let's set the stage with a fascinating comparison. If you've ever watched Doctor Who, you've seen the Doctor travel to the very ends of time and space. But today, we're leaving science fiction behind to explore the real science of time. In Doctor Who, the Doctor travels billions of years into the future and visits the early days of the universe. But what does science say about these extreme points in time? Cosmologists generally agree that our universe began around 13.8 billion years ago with the Big Bang. Imagine running the tape of the universe's history backward. Everything we know today would shrink down to a single, infinitely small point, a singularity. This singularity marked the birth of time and space. But what about before the Big Bang? Astrophysicists like Emma Osborne say that asking what happened before the Big Bang is meaningless, because time itself began with the Big Bang. Time only exists as the universe exists. The moment the universe came into existence is when time started. This idea isn't new. Even the philosopher Thomas Aquinas suggested that asking what came before creation is pointless, because the creation of the universe also meant the creation of time. But what exactly was the Big Bang like, and what happened immediately after? These questions remain open to debate. The proposed singularity was infinitely small and dense, creating theoretical problems that challenge our understanding. Some physicists suggest that singularities might not really exist. Instead, they might signal that our current theories are incomplete. To complicate things further, our universe is mostly made up of mysterious dark matter and dark energy. These unknowns mean we can't fully grasp how the universe behaved in its earliest moments. So, some cosmologists propose alternative ideas, like the existence of a super-universe that contains many universes, including our own. People are questioning more and more the idea that there was a unique beginning. The Big Bang might be the beginning for us, but it could have occurred within a larger super-universe. Ever since the Big Bang, time has flowed in one direction. We call this the arrow of time. Unlike space, which we can move through in any direction, time only moves forward. One explanation for this arrow of time involves entropy. Entropy is a measure of disorder, and the universe's entropy is always increasing. This increase in entropy could be why time moves forward. A shuffled deck of cards has higher entropy than an ordered one. Similarly, the universe tends toward higher entropy. But this theory assumes the universe started in a low entropy state, which isn't entirely proven. Some scientists think there might be multiple universes, each with different initial conditions. We just happen to live in one where entropy increases, making life and time as we know it possible. We can only explain things by looking at earlier events. But when it comes to the Big Bang, we need a different approach. The history of the universe must be consistent, without paradoxes. Adlam compares this to solving a Sudoku puzzle. The universe's history isn't created step by step, but decided all at once in a way that's consistent. So, what about the end of the universe? How might the cosmos finish, and what will happen to the flow of time? Several theories predict different endings for the universe. One is the Big Crunch, where gravity pulls everything back into a singularity. But current evidence suggests the universe's expansion is accelerating, making a Big Crunch unlikely. There doesn't seem to be a plausible way to get to a Big Crunch from current cosmology. Another scenario is the Big Rip, where dark energy tears apart galaxies, stars, and eventually space itself. But this idea requires increasing energy without a clear source, making it less likely. Vacuum decay is another possibility. This involves a sudden change in the Higgs field, creating a bubble with different physical laws that expands and destroys everything. Fortunately, this is only a theoretical possibility and would happen trillions of years from now. The most widely accepted scenario is the heat death of the universe. In this scenario, the universe continues expanding, Stars burn out, and everything spreads out, leading to maximum entropy and a cold, dark universe. With maximum entropy, the arrow of time would lose meaning. No life or conscious beings would exist to perceive time. Time might still pass in some sense, but it would be unobservable and meaningless without the processes that support consciousness and memory. Time has many faces. There's the physical structure of time, which might persist even in a dead universe, and our subjective experience of time, which relies on increasing entropy. Ultimately, our understanding of time's beginning and end is still evolving. These questions push the boundaries of science and philosophy, challenging us to rethink our place in the universe. Let's delve deeper into some fascinating aspects of these theories. For example, if the universe does end in a big crunch, could it possibly lead to another Big Bang? This cyclical model suggests that the universe could be eternally reborn, with time resetting at each new Big Bang. This idea, while speculative, has intrigued many scientists and philosophers. It presents a universe that is constantly renewing itself, with no definitive end. And what about the concept of a multiverse? If our universe is just one of many, each with its own beginning and end, what does that mean for our understanding of time? Could different universes experience time differently? The multiverse theory expands our imagination, suggesting an infinite array of possible universes, each governed by its own unique laws of physics. Considering these possibilities, we realize how much we have yet to discover. Each new piece of the puzzle not only answers old questions but also raises new ones, pushing the boundaries of human knowledge. As we explore the mysteries of time, we must also think about our role in this grand cosmic story. How does our understanding of time shape our perception of life and our place in the universe? That's all for today's journey through time. We hope you enjoyed exploring these cosmic mysteries with us. What do you think about the beginning and end of time? Share your thoughts and questions in the comments below. Don't forget to like, subscribe, and hit the bell icon to stay updated with more cosmic adventures from Cosmic Voyages. Until next time, keep looking up and stay curious.